Hello and welcome to today's session. In today's session, I am going to make you familiar with logistic regression. What is logistic regression? Logistic regression is used for binary classification where we use sigmoid function that takes input as independent variables and produces a probability value between 0 and 1. For example, if we have two classes, class 0 and class 1, if the value of the logistic function for an input is greater than 0.5 threshold value, then it belongs to class 1, otherwise it belongs to class 0. It's referred to as regression because it is the extension of linear regression, but is mainly used for classification problems. Key points. Logistic regression predicts the output of a categorical dependent variable. Therefore, the outcome must be a categorical or discrete value. It can either be yes or no, 0 or 1, true or false, etc. But instead of giving the exact value as 0 and 1, it gives the probabilistic values which lie between 0 and 1. In logistic regression, instead of fitting a regression line, we fit an S-shaped logistic function which predicts two maximum values, 0 or 1. Logistic function, sigmoid function. The sigmoid function is a mathematical function used to map the predicted values to two probabilities. It maps any real value into another value with a range of 0 and 1. The value of the logistic regression must be between 0 and 1, which cannot go beyond this limit. So it forms a curve like the S form. The S-form curve is called the sigmoid function or the logistic function. In logistic regression, we use the concept of the threshold value, which defines the probability of either 0 or 1, such as values above the threshold value tends to 1 and a value below the threshold value tends to 0. Types of logistic regression. On the basis of the categories, logistic regression can be classified into three types. Binomial. In binomial logistic regression, there can be only two possible types of the dependent variables, such as 0 or 1, pass or fail, etc. Multinomial. In multinomial logistic regression, there can be three or more possible unordered types of the dependent variable, such as cat, dogs, or sheep. Ordinal. In ordinal logistic regression, there can be three or more possible ordered types of dependent variables, such as low, medium, or high. So now let me demonstrate now let me demonstrate a Python program in which I have implemented logistic regression. So this is the Python program in which I have implemented logistic regression. Firstly, let me execute this particular Python program in which I have implemented logistic regression. So now let me break this Python program in which I have implemented logistic regression into parts. First is load the Iris dataset. We load the Iris dataset using sklearn.datasets.load underscore Iris and convert it into a pandas data frame for easier manipulation. Binary classification. We convert the multi-class classification problem, which has three species, into a binary classification problem where we classify flowers as setosa or not setosa. Train test split. We split the dataset into training and test sets using train underscore test underscore split. Feature scaling. We standardize the feature using standard scaler, which is often important for algorithms like logistic regression to perform well. Logistic regression. We train the logistic regression model on the scaled training data. Evaluation. We use accuracy, confusion matrix, and classification report to evaluate the model's performance. So I am once again executing this particular Python program in which I have implemented logistic regression. So now let me also explain the output. First point is accuracy. This shows the proportion of correct predictions. Second point is confusion matrix. It shows the number of true positives, false positives, true negatives, and false negatives. Third point is classification report. This gives you a detailed view of precision, recall, and F1 score for each class, setosa and not setosa. Conclusion. The simple logistic regression example trains a model to classify whether a flower is setosa or not setosa. Now the next point is assumptions of logistic regression. We will explore the assumptions of logistic regression, as understanding these assumptions is important to ensure that we are using appropriate application of the model. The assumptions include independent observations. Each observation is independent of the other, meaning there is no correlation between any input variables. Binary dependent variables. It takes the assumption that the dependent variable must be binary, or meaning it can take only two values. For more than two categories, softmax functions are used. Linear relationship between independent variables and log odds. The relationship between the independent variables and the log odds of the dependent variable should be linear. No outliers. There should be no outliers in the data set. Large sample size. The sample size is sufficiently large. So the next point is terminologies involved in logistic regression. Here are some common terms involved in logistic regression. Independent variables, the input characteristics or predictor factors applied to the dependent variables predictions. Dependent variable, the target variable in a logistic regression model which we are trying to predict. Third terminology is logistic function. The formula used to represent how the independent and dependent variables relate to one another. The logistic function transforms the input variables into a probability value between 0 and 1, which represents the likelihood of the dependent variable being 0 or 1. Odds. It is the ratio of something occurring to something not occurring. It is different from probability, as the probability is the ratio of something occurring to everything that could possibly occur. Next terminology is log odds. The log odds, also known as the logit function, is the natural logarithm of the odds. In logistic regression, the log odds of the dependent variable are modeled as a linear combination of the independent variables and the intercept. Coefficient. The logistic regression model's estimated parameters show how the independent and dependent variables relate to one another. Intercept. A constant term in the logistic regression model which represents the log odds when all independent variables are equal to 0. Maximum likelihood estimation. This method used to estimate the coefficients of the logistic regression model, which maximizes the likelihood of observing the data given the model. How does logistic regression work? The logistic regression model transforms the linear regression function continuous value output into categorical value output using a sigmoid function which maps any real valued set of independent variables input into a value between 0 and 1. This function is known as the logistic function. So that's all for today. Thank you for listening me patiently. Let's meet during the next video or during the next session.